Hi, I'm Donnie Rawlings, a senior chemistry major at UMass Amherst and a member of the iCons program. I work in Dr. Deevy's advanced laboratory for iontronic, electronic, and nanomaterials. I work on organic electronics, but I never actually work with any electronic devices. Organic electronics use carbon-based materials, unlike traditional electronics, which use conductors like copper and semiconductors like silicon. I work to improve materials so that other researchers have better options when they design devices. I work with didodecyl parylene diamide and dihexyl naphthalene diamide. I work to improve device performance and consistency by making those dye-molecules into nanoparticles. I do this using directed self-assembly and soap, or more accurately, surfactants, like this dodecyl trimethyl ammonium bromide and this sodium dodecyl benzene sulfonic acid. I mix an aqueous surfactant solution with my chloroform dye solution, and then I shake things up with sound waves. This bath sonicator disturbs the solution and causes tiny dye droplets to form in the larger volume of water. Then I take this mixture and put it on a hot plate that's above the boiling point of water, which is way above the boiling point of chloroform. This causes the chloroform to boil off, and the tiny droplets crystallize into nanoparticles. I measure these nanoparticles using spectroscopy. That means that I use an instrument to shine light on them and look at the light that is absorbed, emitted, or reflected in response. I make alterations to my synthesis procedure and search for trends in overall morphology of nanoparticles and orientation of molecules within the nanoparticles. Nanoparticles are used in organic electronics to achieve more reliable devices. Nanoparticles have shapes and sizes that are larger and more regular than individual molecules. The orientation of molecules within the nanoparticles has a subtle yet important effect on the overall electronic properties, permitting tunability of devices. My research, along with research on device architecture and charge mobility, will push organic electronics towards increased feasibility and more widespread implementation. Thanks for listening. I don't know what to do with my hands.
Just put them down.